Hey guys, these are some guided notes that I've started for you on distance time graphs. So you should have printed this sheet already or drawn it in your notebook, and then we can basically right now finish it together, going over everything we need to know about distance versus time graphs, okay? So first of all, distance versus time graphs means that distance is on the y-axis and time is always on the x-axis, okay? So the y comes first and then the x when you name them, okay? So let's answer some questions and go through this, all right? So the first thing we're going to look at is somebody who's stopped. What does that look like? Well, when you're stopped, where you are, your position or your distance, it doesn't change, okay? That doesn't change. So it doesn't go up and it doesn't go down. So that's why distance versus time for stopped looks like a flat line, like that. It doesn't curve upwards, or even incline, or it doesn't decline. It's flat and straight. All right. The next thing I want to do is these 6 graphs in this table. We're going to look at the first 3, then the second 3, and then answer the question above and below. So the first question here, rank the graphs to the right from fastest to slowest. Write a 1 next to the fastest and a 3 next to the slowest. So our rule here is that steeper, you gotta write this down, steeper is faster. The steeper a line is, the faster it is. So this is the steepest line, that's the fastest. This is the second steepest. And the least steepest, or the most gradual, is the third line there. So that one seemed to be in order there. But let's do it again, but for these lines, okay? So write a 1 next to the fastest again, and a 3 next to the slowest for question 2 here. So the fastest is still the steepest, so steeper is faster. Which one is the steepest out of these 3? Even though it's going down, that one is the steepest. The steepest going down now is still the fastest. This is the second steepest, and this is the most gradual, so it's not very fast at all. Now, let's look at this question right here. What is different between the top row of 3 graphs, these 3, versus these 3? Like, what do these three share in common that is different than what these share in common? Okay, so you might notice that these are all inclines. They're all going up. So let's write the top row is inclined. Okay, and the bottom row, let's look at that. Are those inclined? No, they're declines. They're going down. So what does incline mean versus decline? Incline, or a positive slope, would mean the direction of movement is forward. And a decline would mean that you're going backwards. So if the slope is positive or negative, that tells you the direction they're moving. A positive slope or an incline is moving forward, and a negative slope or a decline is moving backwards, okay? Okay, so what's similar about all 6 of these, though? All 6 of those share something in common. Well, we might notice that they're not curved, that they're all moving actually they're all straight lines, okay? Even if they're going up or down. They're not flat, but they are straight lines, all 6 of these. So what does it mean to have a straight line? It means you're all going at a constant velocity, because the slope is staying the same the whole time. They're constant velocity because they are straight lines. So write down somewhere that a straight line, what does that mean? It means a constant, sorry, that got kind of, that's where I wrote steeper is faster too. Straight line means constant velocity. All right, so there's the front page. Now the back page. These are not straight lines, these are curved graphs. And there's 4 curves that you need to know. This one, it goes up and curves up. This one goes up and flattens out. This one goes down and gets steeper. This one goes down and flattens out. Okay? So you need to know those 4 graphs. So let's take this column and split it in 2. Answer question 1 here. Is it going toward or away? Really what we're going to say for that is it going forward or backward? So remember, forward is when there's an incline, all right? And backward is when there's a decline. So let's just answer that question first for each of these graphs. For question 1, is this an incline or a decline? All right, it's an incline, so it's forward. This one, even though it flattens out, isn't it going up the whole time, right? So it is an incline. That means it's going forward. This one starts out flat, but it never goes upwards. It always is going down. So that one is a decline. So it is backwards. And this one, it's clearly going down the whole time. Even though it flattens out, it never goes back up. So that is a decline, which means it's backwards. So we have 2 graphs that are moving forward and 2 graphs on the bottom that are moving backwards. These 2 are both going up, and these 2 are both going down, even though they curve differently. Now, question 2, we want to say, is it speeding up or slowing down? So for this question, it starts out very flat and it ends up very steep. So if you go from flat to steep, we know steep is fast at the end here, but flat at the beginning is very slow at the beginning. So this one goes flat to steep, so it goes from slow to fast. All right, so we could see that the slope is getting greater and greater, which means it's getting faster and faster. So however the slope changes is how the speed changes, okay? So this one is a speed up because it gets steeper. Does this one get steeper? Oh, it starts off pretty steep, but as you go on, it actually flattens out. So it starts off fast and finishes slow, all right? Because it's kind of flat at the end. It's almost stopped. So this one gets less steep as you go on. It gets flatter, so it's a slow down. Now let's look at this one going backwards now. Does it start out as flat or steep? Right here, it starts out as flat, and at the end, it is very steep. So flat is slow, steep is fast. So it goes from slow to fast. That means it is getting speeding up. This one, okay, is starting out very steep right there, and it finishes very flat. It's kind of the opposite of the last one. So it goes from fast, very steep, to slow, very flat at the end. And it's getting flatter and flatter. As it goes, flattening out, that means it's slowing down. So if it gets steeper like these 2 as it goes on, whether it's steeper up or steeper down, that means it's speeding up. Okay? Both of those are speeding up, but these, it starts out steep. Look at the beginning of both of these. It starts out very steep and it flattens out as it goes forward, flattens out as it goes backwards for this one. But either way, they're flattening out, these 2. So you gotta slow down for those, okay? Now our last question we wanna look at is, what do curve graphs always show? Well, we know straight lines always show constant velocity. But what is the opposite of constant velocity? It's change. So curve graphs always show a change in velocity, which we have a special word for here in physics. Whether it is a speed up change or a slow down change, that is called an acceleration. Curve graphs always show a change in speed, whether it is a speed up or it is a slow down. A change is an acceleration.